Alright, hello, welcome back. This is the second part of the lessons, and we're going to be talking about how to factor a quadratic equation. So, moving on. So, before we even begin talking about how to factor a quadratic equation, we're first going to just look at the solutions of quadratic function. So what do you mean? What do you mean solution? So when we are talking about solution, hopefully you guys remember from last lecture or last video that whenever solution, we're talking about the x-intercepts. So here, there are three different cases of a quadratic equation or quadratic function. So the first scenario is our equation has two x-intercepts, meaning it could have two solutions. So you can see how the graph of a quadratic function, the parabola, is crossing the x-intercept here and here. So it has two solutions or two x-intercepts. So that was the first scenario. And if you look at the second scenario, it could only have one x-intercept. So the one solution occurs at the vertex point over there. And the third scenario is our quadratic function might not have a solution at all, zero intercept, meaning this parabola is way above the x-axis, so it's not even going to cross or intersect on the x-axis. So there are three different scenarios that solutions of the quadratic function, like the number of solutions of the quadratic function. So yeah. So how do we find the solutions or the x-intercepts? So when you have a graph of a quadratic function, you can look at the graph and find, oh, this is the solution or the x-intercept. So by looking at the graph, we can find the solution or x-intercept by looking at the graph. So that's the first option. How about when we just are given equation, the standard form? What if we just have this form? Then we're going to factor. And this is where factoring kicks in. So when we have the standard form, we're going to factor so we can find out the solutions of the problem. So when we factor, remember our standard form looks like ax squared plus bx plus c. And we're going to split that into two terms. Like this. And I'll go ahead and tell in details how to actually factor, how to split into two terms. So what do you mean by factoring? So when we are given, I just wanted to show you what it means to factor so you would have an idea. So when we are given the standard form written as ax squared plus bx plus c, so let's just identify a and b and c. A is 9, right, because that's the number in front of x squared. B is what? You might say 12, but also just notice that there's negative 12. You have to include the sign as well. So I'm going to write negative 12, and then C is simply 4. Anyway, I just wanted to practice that so that you wouldn't be confused. Like, what are A and B and C values? So here they are. So when we are factoring, we are trying to split into two, as you can see over there. And why this is important? Why? Because if you look at the graph of a parabola, what we mean by solution, I just want you to take a notice of the y value of x-intercept. So y value is what? This is y-axis. The y value of the x-intercept is 0, right? So whenever we can make the term 0, so we're looking for the x value that will make the function value 0 over there. So in this problem, suppose this is the right factored form. When x equals 2/3, then this will make our equation 0. Why? As you can see over there, we want to either make the 3x minus 2 0 or the other one 0, which just happened to be the same term. We call that a square term because it's happening twice. But going back, you know whatever 0 times number is always 0. So as long as we have one term 0, the other term doesn't even matter. So let's just look at the scenario where we could make the first term 0. So I want to make 3x minus 2 0, right? As we just talked about it. Okay, now it's getting a little messy. I'm just going to erase it really quick. We want to make the 3x minus 2 0. Okay, that's what we want. That means I'm just going to add 2 on both sides. So they added plus 2 on both sides. And then it became 3x equals 2. Because the 2 and negative 2 can cancel. And then I just wanted x by itself, so I divided both terms by 3. So 3x divided by 3 is just simply x. And 2 divided by 3 is just 2/3. So when x equals 2/3, the first term will be 0. Oh wow, cool. And when the first term is 0, we don't even care about the second term because whatever 0 times 1 is always 0. So that's a concept behind the solving or factoring, because when we solve it, when we factor it, we're gonna now set the factor form or the whole standard form 0, and now we're looking for the x value that will particularly make our function value 0. That was a bit complicated or a long explanation, but as we just do a couple more examples, I hope you get hang of it. So how do we factor our quadratic equation? Well, don't worry, because we're gonna go over step by step, and at the end of it, you'll be like, oh, this was easy. So for us to be able to factor our quadratic equation, we'll actually use this box way. It's a method called box way, X box way, or I actually call it a diamond way, but you can diamond way. All right. Well, so what we are supposed to do to factor, we put the product. It's very simple. So suppose you have a diamond. So on the top of the diamond, we're going to put the product of the two numbers, meaning a and c. A and c. So a is a value in front of x squared, and then c is a value that's just by itself. And then we're going to put and for the bottom value, we're going to put the b value, which is just in front of x. So we're just going to practice what it means. So suppose we do have a diamond, and for this example case, what is our a value again? Well, I don't see any value in front of x squared. Well, that means there's 1. Whenever we have 1 in front of variable, we could just skip it. And what's our b value? It's 4, right? That's what's in front of x. And what's our c value? Is it 12? No, it's negative 12. I know a lot of students make mistakes. They always forget the sign, either positive sign or negative sign. But this is very crucial because if you forget the negative sign, then that becomes a whole complete different quadratic function. So now that we have all a, b, c values identified, we're going to put so for the top diamond value, what are we putting? We're putting the product of a and c. Meaning 1 times negative 12, meaning it's just going to be negative 12. And our bottom value, which will be our b value, is simply 4. So now this is what we are doing. So we have negative 12 on the top and then 4 on the bottom. And we are going to try to find out these two values. They will give us negative 12 when we multiply and positive 4 when we add. So I'm going to think about a couple of numbers. How about 4 and 3? Oh, okay. So 4 and 3 gives me what? Just 12. Okay, that's wrong. How about negative 4 and 3? That gives me negative 12. But then when I add it, that doesn't give me 4. How about, oh, I know. How about 6 and 2? No, 6 and negative 2. 6 times negative 2 indeed gives us negative 12. Oh my gosh, take a look at this. 6 plus negative 2 gives us 4. So we did get 4 as a sum and negative 12 as a product. So we have found the two values that we'll be putting on the side of our diamond. It doesn't really matter if you put 6 here and negative 2 on the other side. It could be vice versa, so don't stress about that. So what do we do with these two values? So now that our goal of using this diamond method was for us to find out the two values on the side. So what do we do with this? So we're going to be simply we're going to write in this term. You saw how when we factor the quadratic function, the standard form, we had this two terms, right? So we have 2x plus kind of term, and what we have just found out is the value that we'll be putting here. So we found that's 6 and that's -2. So we have successfully factored the quadratic equation into factor form. And I want to make sure, wait, are you saying that are you saying x plus 6 and x minus 2 is the same as x squared plus 4x minus 12? So what we are trying to say is, you're saying this is equal to x squared plus 4x minus 12? Yes. So we're going to verify this. How? Let's see. So I'm going to multiply these out slowly, term by term. Okay, it's getting a bit messy, but you'll see. So x times x. X times x is what? X squared. And x times minus 2 is just simply -2x. And then 6 times x is 6x. And then 6 times -2 lastly is -12. And if we combine like terms, we have x squared, and then we have two like terms, and I'm going to put what's -2x plus 6x, simply 4x, and then -12 is just by its own. Yeah, so we indeed have proved that the two terms, the factor terms, is the same as our standard form. So that is the beauty of our quadratic function factoring. Okay. So we're going to work on our second example. So x squared minus 9x plus 20. And let's just verify each value. So what's our a value is 1. Our b value is -9. And our c value is 20. Yeah, again, whenever there's no actual number in front of x squared, we mathematicians are too lazy to put 1 in front of variable, that they just indicate, like, no, if there's no value, then we just know that it's 1. So using the diamond method, on the top value, what do we put? We put the product of AC. A times C. And then on the bottom of the diamond, we just put the B value. So on our top value, A times C is just simply 20. And our B value is -9. Okay. And now we're going to try to think of a two value that gives us a product and the sum. So we gotta just find these two numbers that will give us 20 when we multiply it together, and that will give us -9 when we sum it together. So I'm going to try to think of some possible numbers. Okay, how about 4 and 5? 4 and 5 definitely gives us 20 when we multiply, but not so much -9. Why not? Because when we add it together, it gives us +9 instead of -9. Oh, I got an idea. What about if I multiply -4 times -5? That gives us +20, and that gives us -4 plus -5, and it gives us -9. So we found these two values, -4 and -5. So what do we do now? Now we're just putting that in this form, negative x minus 4, x minus 5. And this is the factor form of x squared minus 9x plus 20. Yeah. So we have indeed factored into the factor forms. Maybe if you want to check if that's the right answer, you can once again multiply x times x equals x squared, and now x times negative 5 is negative 5x, and x times, or negative 4 times x is negative 4x, and lastly negative 4 times negative 5 is positive 20. Sorry for the messy work. And if you combine like terms, it will simply be x squared minus 9x plus 20, which we first started with. So that wasn't too hard. Okay, so but are there scenarios that we can't really find those two numbers that will give us the product on the top and then the sum at the bottom? Like what if we can't find the number, these two values? Like I tried everything but I still couldn't find it. What do I do? What if I can't find the two numbers with this method? What do we do? Well, don't worry, because we still have a way to find the solutions of our quadratic function. So this looks really, really difficult, but this formula gives us the very values of when the function is crossing the x-axis. So this formula gives the solution. So x equals negative b plus minus b squared, x equals negative b plus minus square root b squared negative 4ac all over 2a. Just remember that these a, b, c value are still the same value from our standard form. If you can't remember, our standard form goes ax squared plus bx plus c. So using all this coefficient value, we're plugging that into this formula and we'll get the answer. And but then I thought we'll be looking for two values, two answers, usually. Well, don't worry about that, because this positive and minus sign over here gives us two different values, because you are essentially either adding this value to negative b and subtracting this value to negative b. So it will actually give us two different values. So using this formula, so this is actually called the quadratic formula. Let me just write it down really quick. Quadratic formula. Okay, I don't have a space, but formula. I'm sorry for. Yeah, sorry. Alright, cool. We're going to use this method. Okay, let's just verify what are the a, b, c value. A equals negative 1 because that's what's in front of x squared. B equals 3. C equals 8. So we're gonna use this value. Just we're gonna stick with this. Do not be afraid, even though that formula looks very intimidating. So our x equals negative b. What's our b value? 3 plus minus square root b squared. What's b squared? 3 squared negative 4ac. What's a? Negative 1. Okay, hopefully I have a space to put. Let me try it again. Negative 1 times. Oops, I'm just like running out of space. Okay, let me negative 1. Oh, this is bad. Okay, I did it. Negative 1 over 8. All over 2a, right? 2. Once again, negative 1. Let's do this. So negative 3 plus minus 3 squared is 9. Sorry, square root. Negative 4 times negative 1 is positive 4 times 8 gives us 32. All over 2 times negative 1 is negative 2. This gives us negative 3 plus minus, we're just going to simplify. 9 plus 32 is 41. Equals negative 2. So if you put this value into the calculator, you'll get, so I'm saying x equals negative 3 plus 41 over 2, and because we have two solutions, right? X equals negative 3 minus square root of 41 all over, sorry, I forgot the negative sign here, negative 2. So we have two solutions using the quadratic formula. It does indeed give us two different solutions. And if you punch that into the calculator, and I'm going to show you the decimal, but so if you look at that solution, that function, it was what? X negative x squared. I'm sorry, I actually have to go back really. So plus 3x plus 8. So these two values will be matching to the solution that we found on the previous page. And this is what it means. We have indeed found the x-intercepts where it crosses the x-axis, and we do get the two solutions. That wasn't too bad. So make sure you practice a lot of problems, and the more you do it, the easier it will get. So yeah, thanks for watching the video. Hope this helped. I'll see you later. Bye.